Hi, my name is Wissal Benjira, and in this video I will present SDG Knowledge Graph, a framework to automatically compute sustainable development indicators using open data sources. The Sustainable Development Goals, or SDGs, are 17 global goals set by the United Nations for a better and more sustainable future. All countries have to track their progress using more than 200 quantitative indicators. These indicators guide governments and organizations in designing, monitoring, and evaluating public policies. But in practice, only a third have a clear methodology and regularly available data. Meanwhile, tons of valuable open datasets exist. Therefore, we can formulate the following challenges. How can we link fragmented open data sources to the official SDG indicators? And how can we automate the computation process of these indicators while keeping it transparent and verifiable? This leads to the definition of SDG Knowledge Graph, a framework that connects open data to SDG indicators using a knowledge graph approach. It brings together SDG definitions, open data sources, and computation logic into a single queryable structure. First, the process begins with the user's data upload. We extract the schema and build the metadata graph following the OpenSDG format. Next, it automatically maps data attributes to SDG attributes, combining rules with LLMs. The mapping can be reviewed and refined if needed. Then an indicator is selected along with spatio-temporal filters. And based on this, several candidate subgraphs are generated. If there are overlapping sources, a resolution strategy is applied using trust metric score. Finally, the indicator is computed and the result is visualized. Let's see it into action. We start by testing the connection to both the graph database and the LLM. Now, let's take a look at the SDG graph. It includes the goals, targets, and other nodes that can be added optionally. Now, let's move to importing a dataset. We upload the database from INSEE, which is the French official statistical provider, to represent the concept of population. The data comes with both a CSV file and a GeoJSON file for spatial representation. A sample of the dataset is displayed along with the generated metadata graph showing key attributes such as spatial and temporal granularity, reliability, and completeness. Then we use the LLM-based mapping feature to align the dataset to the concepts. We manually review and adjust the mapping before integrating it into the knowledge graph. This process can be repeated for each new dataset we want to connect. Next, we define a use case. Let's see how women access public transport in Hauts-de-Seine region next to Paris since 2017. The system automatically identifies relevant query parameters such as spatial area, time window, and disaggregation. A corresponding subgraph is generated showing the indicator, connected concepts, and dataset available. For the population concept, several datasets match. We then select the best one based on the TSM. We can now compute the indicator. The system generates an execution plan based on the official formula and the selected query parameters. In this case, we filter the result based on the content of the dataset. The output lets us observe how accessibility has evolved over time and across locations. We notice a significant increase in accessibility, especially in 2022, during the preparation for the Paris Olympic Games, because new infrastructures were added, including the extension of the underground Line 4 in Paris. So, the SDG knowledge graph combines a knowledge graph representation with LLM-based mapping to align open data with SDG indicators. It allows query-driven computation with spatio-temporal filtering, and it also generates execution plan from the graph's topology. Thank you for your attention.